All right, welcome to another short video. Um, in this one, we're going to be proving the formula of the inverse of a 2 by 2 matrix. So in the examples in the inverse, we established that the inverse of a 2 by 2 matrix is simply 1 over A, that's a D, AD minus BC multiplied by D negative B negative C, that's a D, A. And so what I want to do in this video is to show how you go, or how you get this formula. It doesn't magically just like drop from the heavens. No, there is a way to derive this formula, and it involves doing the method that we did with a 3 by 3 matrix. So what we're going to do now is going to put this in an augmented matrix. So that's a D, A, B, C, D, and then on the right side it's inverse. And so what we have to do is the same story as finding the inverse of any matrix, which is putting the inverse on the left side, and then the right side will expose our inverse. But what we have here is we have variables A, B, and C, and D. But that's no biggie. That's just pretty much implying that it doesn't matter what number these letters are. This will still give us the general formula. So what we can first do is divide the first row by 1 over A. And so what that gives us is our leading one. We will have, of course, B over A. And then C, or the second row, just remains the same. And then here we have 1 over A, and then 0. So what we're going to do now is we're just going to zero out this C. And the way we do that is we just get the second row and subtract it by C times the first row. And that will give us our new C. And so the first row will remain the same. And then we have C minus C, so that'll be 0. And then here we have D minus BC over A. And so what we end up having is D minus BC over A. And then here we'll have negative C over A, then R1. So on the left side we have some weird looking fraction, and then there's the solely D. And so what we can do is we can combine this into having a single denominator. And if you remember how to do that, we just multiply the or each ones by their corresponding denominator. So because D is just D over 1, all we have to do is just multiply it by 1, which would be A over A. And so this would be AD over A minus BC over A. And then we can just combine those two to just be AD minus BC over A. So I'm just going to go ahead and rewrite this as 1 B over A, 0 AD minus BC over A, then not negative, 1 over A, 0, negative C over A, then 1. And then you can see here that we can see our AD minus BC forming here. And so now what we're going to do is we are going to multiply the second row by the inverse of AD minus BC over A. So this would just be A, that's a D, AD minus BC, then A on the top, multiplied by row 2, and that will give us our new row 2. And so that will simply give us 1, 0, B over A, so give us our 1. And on the right side, we only messed around with the second row, so the first one remains untouched. So 1 over A, 0. And then here, we will have, well, because it's negative C over A multiplied by A over AD minus BC, the A's will cancel out. So we're just left with negative C over AD minus BC. And then on the right side, we have A over AD minus BC. And so lastly, we're almost done. All we have to do is just get rid of the B over A. And that is as simple as multiplying or taking the first row, subtracting of the second row. And so what we'll get is second row remains untouched. First row would be 1, 0. Then again, the second row remains untouched. And then for the first row on the right side, we'll just simply get let's see. So negative BA so what ends up happening is we will get D over AD minus BC, and then on the right side it would be negative B AD minus BC. Yeah, so it'll be, D over AD minus BC, and then the second column would be negative B over AD minus BC. You have to do a little bit of algebra to get this, but you should be able to get this. And yep, on the left side we have our inverse, so the right side would be our answer. And then what we can do is, because they all have a common denominator, we can just factor out 1 over AD minus BC, and then we'll have D, negative C, negative B, and A. This is an A. And that's the proof of the inverse of a 2 by 2 matrix. This is the formula that we can use. So yeah, this was a little bit longer, but it's a proof, so yeah. I guess I'll see you in the next video.